Hi, today we're going to be talking about the point-slope form. At the beginning of the chapter we really spent a lot of time on the slope-intercept form, and the point-slope form is just another type of equation that you can make using linear relationships. We'll be also learning the standard form for linear equations. Each of the three types have their own positives and negatives, or I guess advantages we want to say. So we always want to choose the thing that seems the easiest for us to do given the information we have. In the last section that we worked in, we were given a point and a slope. And when we had that, we would plug into the y equals mx plus b formula and solve for b. We can use the same information to plug into the point-slope formula. The point-slope formula is y minus y sub 1 equals m times x minus x sub 1. Y sub 1 and x sub 1 are made up of the points that you're given in the one coordinate pair that you have. Okay? So using the formula and the points that we have, 2, 3, and the slope of 4, we're going to just plug in to the point slope form. Okay, I think you can see that this is a lot, maybe a lot quicker to use rather than plugging into the slope intercept form to find b and then go back and rewrite the equation. So if you're given 2 points and no slope, we would use the same method similar to what we did with the slope-intercept form, and that is find the slope, but then plug 1 point into the point-slope form and solve that way. Again, a lot of this is preference. Okay, what seems easier to you as you're working. And end up with m equals negative 2. So if I have m equals negative 2 and I plug it into the point slope form using, let's use 3 and negative 2, 3 as my point. So I have negative 2 here, and then x minus negative 2, which would be x plus 2. So y minus 3 equals negative 2x minus 4. Y equals negative 2x plus 1. It still seems that all roads lead to y equals mx plus b, which is the easiest way, short of plotting the 2 points, to plot any given linear equation. The other possible type of question you might see is being given a graph with 2 points on the line, where you would count the slope and use one of the points in the point-slope form. So if this were drawn on a graph, I would be able to count the slope and see that the slope is a negative 1 on this line. And then I could use either one of these points into the point-slope formula. Y minus negative 1 equals negative 1 times x minus 2, and y plus 1 equals negative 1 times x minus 2. I do want to say to you that sometimes you are told to leave your solution in the point slope form, and so this is what it would look like. You would simplify here on this side, but on this side you would leave that x minus the x sub 1 in the parentheses. You wouldn't do the distributive property. So the last thing I wanted to do is just talk to you about how to set up the word problem that's on the worksheet or the study guide. It talks about oranges weighing various weights depending on how many there were. 1 orange is 0.4 pounds, 16 oranges is 8.8 pounds. So how would you write an equation that would represent this relationship? Well, what I can tell you is oranges, oranges, pounds, pounds. If we were to graph this, this would make a linear equation, wouldn't it? So I'm going to treat these like they're coordinate pairs. So this is one, and this is the other coordinate pair that represents the relationship between the number of oranges and their weight. The other thing I know is every time I add an orange, I'm adding 0.4 pounds. That is my rate of change in the weight, which is 0.4. And the rate of change is my slope. So now you know your slope, and you have 2 points that are on the line. Can you use the point slope form using 1 point and determine a linear equation to help you solve the problem? I will tell you to use your slope and to use 16, 8, 8 for your point. This should set you on your way. Stop the vodcast, try the extra problems on the sheet, and then on the back of the sheet complete the odd number problems. See you tomorrow.